Now let's prove the other distributive law, which is that A intersection B union C is A intersection B union A intersection C. So again we will use both the methods that we used to prove the previous distributive law. The first method was to pick an arbitrary element from the set on the left hand side and show that it belongs to the set on the right hand side, thereby proving that the left hand side is a subset of the right hand side, and then doing the converse, which is taking an element from the set on the right hand side and showing that it lies in the set on the left hand side as well, thus showing that the right hand side is a subset of the left hand side. So to prove that the left hand side and the right hand side are the same set, we have to first prove that the left hand side is a subset of the right hand side. So let's pick an arbitrary element from the set on the left hand side and show that it belongs to the set on the right hand side. So let's say X belongs to A intersection B union C. If X belongs to the intersection of these two sets, X must be a common element of both those sets. So it must be the case that X belongs to A and X belongs to B union C. Now our goal is to show that X belongs to the set on the right hand side. So we have to show that either X belongs to A intersection B or it belongs to A intersection C. Now we already know that X belongs to A, and the other piece of information we are given is that X belongs to B union C. So possibility 1 is that X belongs to A and X belongs to B. Possibility 2 is that X belongs to A and X does not belong to B. X must belong to A, that is given to us, but it's not clear whether X belongs to B or not. We are given that X belongs to the union of B and C. So we have divided up this into two possibilities. Either X belongs to either X belongs to B or it does not belong to B. Now if X belongs to B and X belongs to A, then X must belong to A intersection B. Now what if X belongs to A and X does not belong to B? If X does not belong to B, then X must belong to C, because if X belongs to the union of B and C, and if X doesn't lie in B, then it must be an element of C. So if X does not belong to C, it must be that X belongs to C. Okay, this means X belongs to A and X belongs to C. If X belongs to both A and C, that means X belongs to the intersection of A and C. So these are the two possibilities. Either X belongs to A intersection B or X belongs to A intersection C. One of these two possibilities must be true. So if we take the union of these two sets, X must belong to their union. If X belongs to this set or X belongs to this set, X must belong to their union. And this is the set on the right hand side. A intersection B union A intersection C is what we have on the right hand side. So we have proven that the left hand side is a subset of the right hand side.